Okay, let's just handle the entire section B. So say answer our question, 5 marks each if used for self-assessment. So any question in section B you find that is out of 5. So yeah, so even question 1, your aim is to score 5 marks. So the question says the code below builds a simple linear regression model. Carefully read the code and then explain in plain language what each block does. So here, carefully read the code and then explain in plain language, explaining what each block does. So we count blocks as in 1, block 1, line of code, 2, just like that. Okay. So in short, what this question wants from you is to, if you come to this line of code, what exactly is this line doing? Then you come to the second one. Then you come to this also. And then you come to this, not until the last one. So let's start with the first one. We are saying from scikit-learn.linear model, import linear regression. Import linear regression. Then the second one, we are saying import NumPy as NP. So let's handle the first one. Remember, if you attended residentials, we talked about packages, modules, and libraries. By definition, we said a module, like the collection of codes, when you put them together, you form a module. And then a collection of modules is what you call a package. So something that has got a lot of packages inside, a lot of modules inside, you call it a package. And a single compound code is what you call. Yes, how are you?
I'm fine, thank you. Some of my colleagues are not online. Kindly asking if you can record the session.
Unless if you do it on your side, there's no problem. Mine on usually, yeah. If anyone can record, there's no problem.
Oh, okay. Anyone from the group kindly assist. Some of our members are offline. Thank you.
Oh, all right. So on this one, always whenever you're building a system, an AI system or one, it's layer that entirely you can build everything. In most cases, you just import some of the things that others have already done, and then you use them on your system. So in most cases, you'll find you need to start by importing the modules or packages that you'd want to use within the program that you're building. So here, in short, we are interested, looking at our model, we are interested in importing a linear model. Okay, so scikit-learn is a package. So in short, it's package. We are saying inside the scikit-learn, which is this one, there is a module, which is linear model. Inside there's a module, this one. And then inside this module, there is a class called linear regression. Linear regression is a class, and in programming, we basically use a class to create a method, to create an object, sorry. So here we want to actually import a class inside a model. So if it's explaining, you can just say we have a package called sklearn, and then we have a model, which is basically a module called linear model. And then from the linear module, we are importing a class called linear regression. That's all. And then the second one, we are saying import NumPy as NP. NumPy is also a package because it has got a number of mathematical functions and modules inside that you can use. So we're saying import NumPy as NP. When you use as, whatever follows here is like an assignment, a short assignment to the package or the module. So this is an alias of NumPy. So after just this, instead of using NumPy, if we want to use this package, we'll be just saying NP, because we've said NP is an alias of NumPy. So here, if you were to explain, you're just saying you're importing a package and you are making it short, okay, to NP, which is just an alias. And then now you come to this part. If for instance, sorry, if there's a question as I'm explaining, please, you can feel free to stop me, and then I can go through that. Okay. Okay, so here, this is more like a data set for us. I'm saying more like a data set. But here we have two values, X and Y, if you see here. One is the value for the prediction, and then the other one is the one that you use to train the model. Okay, but there's one thing which is very interesting on this part, which is different to the other. This array, the 1, 2, 3, 4, 5 are inside square brackets. But here it's just a single square bracket having all these arrays that you're seeing. When you have an array like this, it means it's in 2D, okay, 2 dimension. And then this one is in 1 dimension. Okay, hope that is clear. So you have the X values and the Y values for the prediction. And then when you come to this part, remember, we are talking about the model, okay, which we know is linear model, but we're interested in the class, which is there. And in our case, it's linear regression. So here we are saying it's like we're creating an object. So you're saying model is equal to linear regression. Okay, meaning now when we just go upon model, which we know it's holding this class, we can assign whatever we want, depending on what we want. So no wonder we are saying model.fit X, comma, Y. Okay, so now we are fitting the X and the Y values. Okay. And then the second last, which is the main one, the last one is when we are now printing out, we are saying Y predict is equal to, okay. So now here is where we've created an object of the class, of this class, linear regression, which is Y predict. So we are saying model.predict and then np.array 6. Here the 6, if you look at this ends at 5. So we are saying 6, in short, we are trying to predict the new value, which isn't here. These correspond with each other, 1 with 1.2 with this, and this. Then what about how can we predict this value? We need to have the X value that will help us predict this. No wonder here we are saying 6. Okay, so what we expect is to have this value, which is on 0, 1, 2, 3, 4, 5, on index number 6, on index 5 in particular. And then the last one is where now you print out, okay, you get the predicted value for the input 6. Okay, so you say predict for X is equal to 6. This is a string, it's going to be printed out exactly the same. But here, this one will actually print the answer of what you've predicted on index 0. So basically, I've explained a lot for the sake of just your understanding. Otherwise, you will just go straight when it comes to answering. Remember, it's just 5 marks. So the beauty is after this, I'll share with you this one. There is even an explanation to help you. Okay, so this is how you're supposed to answer it. So import linear class from this, the class implement ordinary, import numpy. Okay, import numpy, a library from numerical, yeah, create a 2D. You'll find time you can go through all these nicely. But basically, that's how you're supposed to answer question 1. for section B. Any question before I go to question 2? Okay, I believe that is clear. So let's come to question 2. So question 2, write the formula for sigmoid function, which is this one, and the ReLU function. So here, if you remember, it's under deep learning. We talked about, I think during residentials, we talked about 3 activation functions and how you can use them. So here saying write the formula for the sigmoid function and the ReLU function. So if you know, when it comes to a neural network, the use of an activation function, it becomes easy for you to remember even the formula, because you know what each and every activation function is supposed to do. So since here the question has specified that you need to have the sigmoid function and the ReLU function, then you just write the formulas. So for sigmoid, if you use the actual Greek letter, you write it like this, sigmoid of x. But you can even use f of x if you want. Okay, is equal to 1 over, okay, do I have, let's see, do I have, this one is, do I have a normal formula where if we use LaTeX, we can have the normal formulas. Okay, but anyway, I believe you still remember. So we'll say sigmoid, the formula is, so you can, if you use f, we'll say f of x is equal to 1 over 1 plus e to the power x. Okay, that's a formula for sigmoid. And then e is basically a constant. Okay, there's a value for e. So if I ask you to solve, then definitely you need to know the value of e. And then for the rectified linear unit, for this one, you can say f of x is equal to maximum, and then open parentheses, you say 0, x close. Okay, we know for this one, you can only have 2 possible results, okay, a 0 or the number of x itself. So if they say x is equal to 2, and then you know definitely the answer is going to be 2. But if they say x is equal to -5, you know any number below 0 is 0. Okay, so any negative number still gives you a 0. So this one is 0, x, where x, if it's a positive, is the same number. That's it about the formula. Okay. Okay, so the Vivian said, compute the value of each function when x is equal to 2. So you use the same formula. If x is equal to 2, okay, it means on the value for e, okay, you replace with a constant, and then on the part for the x you put 2. Okay, so here it means it's going to be 1, okay, to the power e to the power -2. So okay, 1 plus e to the power 2. Okay, so if you can compute, you have an answer which is basically approximate to this one. Okay, which is approximate 0. So you just have to replace where there's e, you put a constant, and where there's x, you put the value that you've been given. Okay, and then you solve. In most cases, it doesn't need you to even use a calculator. The number, the x value that you'll be given is something that you can easily solve by yourself. If maybe it might give you some points, you can leave it as a fraction. It's still the same. So if, for instance, you find it's 3 over 2, you know it will give you 0 point something. You can leave it as a fraction just like that. Still it's correct. Okay, and then if it's using the red, remember 2 is a positive number, so the answer is 2 without even solving. But you can just follow the formula. You write the formula, and then you find the answer, which is 2. But logically, you just have to know that when it's a positive number, the answer is the same. Okay, and then C, which of the two functions outputs 0 for all negative inputs? So this one, I think I even explained. Instead of all negative inputs, they give you a 0. So that's question 2. Any question? Okay, so we go to question 3. Consider the following TensorFlow keras model. Answer the question below for the code. Okay, so also there's a code. You need to understand the code, and then that's when you can answer. So consider the following TensorFlow. Okay, so we know you are importing TensorFlow, and you're saying as TF, which is an alias of TensorFlow. Then model, you said this is sequential. Okay, layer.dense 10. Okay, activation, you've used the value. The input shape, you've said 5. And then down there, you said 1. And then activation, you've used 6. Okay, so model is summary. Okay. So starting with consider the following, answer the question below. Okay, so A, what do the two dense layers do? Okay, if you see we have 2. 1, 2. Okay, state the number of neurons in each layer. State the number of neurons in each layer. Okay, so you need to understand how you implement an activation function when it comes to programming. Where do you put the number of neurons? Where do you put the type of activation function that you've chosen, and also the structure of that particular neural network? So what do the two dense layers do? State the number of neurons in each layer. So we are saying the first dense layer, remember, we are talking about this one. Okay, is a fully connected layer. If you go back to the structure of the neural network, we said it has got input, fully connected, and output. So the first dense layer, the one on top there, is a fully connected, okay, hidden layer with 10 neurons. So the first part, when you talk of a hidden layer, you're talking about the artificial neurons. So we are saying there are 10. Okay. And then there's a 5 here, which is the input shape. Okay, the input. So I'm saying each of the 5 input features is connected to each of the 10 neurons. So in short, this gives the structure of your hidden layer. So all 10 are connected to the input shape. And then for this one, it's the same. It means now here, okay, you have one neuron. Okay, you have one neuron, and for the implementation, you are using now the sigmoid. And remember also sigmoid has got a certain value range, which is always on the positive side. Okay, those which are closer to 1 are considered to be are considered to be true if we go the binary way, and those which are below are considered to be false. Okay, so depending with what you are trying to achieve, you can have 2 activation functions for a specific reason. So you see dense layer output 1, okay, and then it takes or 10 values from the previous layer and then assigns by, okay, sigmoid between single zeros and 1, okay, which is used for binary classification. Yeah, so basically that's it. So for the output, you're using the sigmoid. For the input, to structure your neural network, you use the RELU. And then B, why might the RELU be a good choice for the hidden layer and sigmoid for the output layer in a binary classification task? Binary classification, 2 possible results, a 1 or a 0, a true or a false, good or bad, whether it's email, it's normal inbox, or spam. That's binary classification. So I say, why might the RELU be good when it comes to the hidden layer and the sigmoid? Why can it be good to use it on the output layer to output the results? So they're saying RELU is computationally efficient, promotes space activation, and it also can mitigate the vanishing gradient problem for positive acceleration. This helps faster convenience and works well in deep neural network. Yeah. Or in short, the best way you can answer it in plain English. And so why you're using the RELU? Remember the output for the RELU. All negatives are zeros, and all positives are actually the same number. Okay. So if you're using the RELU when it comes to the hidden layer, it means that on the hidden layer, all the negatives, before they even reach the output layer, you would have already sieved them, and you only remain with a positive. Okay? And if you remain with a positive, now sigmoid will work better because sigmoid doesn't work with the negatives. Okay? It will give you now the output in two possible results, which is 0 or 1. So even if you can have a number which can say maybe 10 or 3, which is that number when you use a value which is in between 0 and 1. Okay, where those values which are closer to 1 will be 1, and those which are less than say 4 or 5, those are the ones that are considered to be 0 or a negative. So that's where this explanation also comes in for the output layer. And we just want 2 possible results. And then C, we are saying, what does input shape equal to 5? Or what does input shape equal to 5? And then specify about the input data. I think this also, the answer was even given already here. Each of the 5 input features is connected to each of these 10 neurons. So already there's a clue from just the first answer. Okay. So the input shape equal to 5, remember in normal mathematics or programming, whatever you put here before a single equal sign, this is a variable, okay, holding the value of 5. Meaning within the code, you won't be calling upon 5, but you call upon the variable, and the value is what is going to be outputted. So we are saying input shape 5 specifies that each input sample is a 1-dimension vector of length 5. Remember, we talked about this gives the shape of your neural network. So no wonder here we're saying 1D vector of 5. Okay, so these are 5 features, for example. So the batch dimension is simply the model array shape, like passes exactly. So it's the connection. You have 10 neurons, okay, and then you connect them to the vector quantity specified to be 5. Okay. So basically that's it. This gives the shape of a neural network on how your neurons are going to be connected. And then, okay, that's number C. That's number C. So question 3, this is the answer. Any question where you feel maybe you are not clear? Okay. So I think the last question in section B is K-means in a nutshell. And okay. So K-means in a nutshell, read the code, then answer the questions that follows. So from scikit or sklearn.cluster import K, by now I think you know exactly what this means, and then also import numpy np. Also they've given us also this. Okay. Okay, and then here they've used k-means, and then you have put x. Okay, then print this k-means cluster, and then k-means labels. Okay. Okay, so the first thing here is understanding your code, and then the questions will be easy to answer. So if you look at this setup, it's almost the same with the one we discussed earlier on. The only difference is when it comes to this part. Okay, the model that has been chosen to be used. Okay, even here you can tell about the choice of your model from what you've actually imported. So the first question says, what does setting n clusters equal to 2 instruct the algorithm to do? Also, during residentials, we talked about clusters. Clusters are just like groups. So in short, they are saying, what does setting n groups equal to 2 instruct the algorithm to do? Okay. So I think that's a very straightforward question. Okay, we are creating 2 clusters. We are creating 2 groups. That's what this means. We are saying setting n clusters equal to 2 tells K means to partition the data set into 2 clusters or 2 groups. You partition data into 2 groups. When you partition data into 2 groups, whatever you have as input, you'll be putting on those 2 groups based with similarities. And that's how K clustering means. So sometimes there can be a question where they say, okay, K is equal to 3. Just know that you are grouping your data set into 3 clusters or 3 groups. Okay. Okay. And when you group, the purpose of grouping is to find a center, a centroid, a point where it's a center for all the things which are in that particular group. I think during the residentials, I gave an example building clinic. Okay, so it's the same thing now when you're dealing with the code. You basically put it this way. You are saying K means n clusters equal to 2, random state equal to 0. So you've clustered your data set that you have here on top into 2 clusters. And then in simple words, what does the K means algorithm try to do with the data? Also, the answer obviously we've gotten from there. So it tries to put the data into specified number of clusters so that points in the same cluster are similar or close in feature space, and points in different clusters are dissimilar, which is far from each other. Yeah, so this question and this are just similar. The key is clustering. When you cluster, The goal is to make sure you find a centroid or a center point, and you put your data based with their similarities. So I think this is just an example of how you're going to try to do with the data points. Okay, so fix initial centroid, assign each point to the nearest centroid, update each centroid to the means of the points assigned to it, then the bits assigned and update until the goal is to minimize within cluster variances. Yeah, English we even handle during the attentions. So what is the meaning of the printed cluster centers and labels? Okay, so let's go back to the code. Okay. So we have a print function here for cluster centers, and we have a print function here for cluster labels. But these are basically they're just strings. We are basically using our function on k means dot cluster centers, this part, and k means dot labels. Okay. So what is the meaning of the printed cluster centers and labels? So like I said, you are considering this. K means dot cluster centers one. K means dot labels here. So the question is just all about these two lines of code. Okay. So for cluster centers, you have a cluster, you have a group. Now the center, that's the cluster center. So cluster centers are the coordinates of the centroid for each point in the feature space. So for this data set, each center is a 2D point since the data is a 2D. If we look at the structure of our data set, it's actually a 2D. So they represent the average location of each point. So you have a centroid, you have a cluster, and then you have a middle point, which we are saying is the middle point is the centroid. But how do you come up with a middle point? Remember, if it's a point, it means it has got coordinates, latitude and longitude, to define that particular point. Okay, and whatever positions that the things in that cluster are also, remember that are positioned. Okay, so a cluster center, that's why you're saying there are coordinates of the centroid for each cluster in the feature space. So you have one group and a point inside. Okay. And that point is basically coordinates, latitude, longitude. And that's what defines a center. And then you have cluster labels. K means dot labels. So just from the word itself, labeling something. We are saying these are integer assignments, e.g. 0 or 1, indicating which cluster each original data points belong to. So it's like you are putting, or assigning a label, okay, to whatever features you have, depending with which cluster they originated from. Okay. So basically that's it about labels and centers when it comes to a cluster. Okay, so this one had only, okay. Yeah, then this is section C. Yeah, so let's see about question 4. K means in a nutshell, read the code and then answer the questions that follow. So any question concerning question 4? Okay, I believe there's no question. Any other question that you'd want us to handle together? I think we are remaining with a few minutes. Any other question that you'd want us to do it together?
Sir, there's no section C.
I
We have
believe that.
tackled section B only.
Yeah, we're only tackling the questions that you feel you needed some help due to time.
Okay.
So
Oh.
one mentioned that the whole section B, because it has got obvious some codes and all that. So I was asking you section C, do you have any question that you'd want us to go through together? I believe we can handle on one or two due to time. That's 22, I need to have another appointment. So do you have any questions in section C that we can do together?
Maybe you can help with the first question.
Oh, okay.
Then is this how questions are in the exam? Is this how you prepare the questions in the exam for the final paper?
The same format. Section B, it's entirely code. Section A, those straightforward ones, and then section C, 30 marks each question.
Oh, okay.
Okay, so choose according to level. So section C, you answer according to the section. There is the first part is for the bachelor's level, and then the second part is for the master's level. So I don't know if I specify. Okay, so I don't know, you meant question one on the master side or even the one for the bachelor's?
Sorry?
You meant section C has got two parts for bachelor's and master's. So you meant for the master's?
Yes, maybe you tackle one question from the master's, then one from the bachelor's.
Okay.
Is it possible?
It is. Okay. So what we'll do is, let me just check the actual tutorial sheet, how the question was. Okay, so bachelor's level. Okay, so question one for bachelor's level. How would you set up a natural language pipeline to detect positive and negative sentiment in customer feedback? Okay. Include pre-processing, model selection, and evaluation. 30 marks. Okay. And then let's see on the master side. In the enforcement learning for automation driving, what are they? Okay. So, for natural language processing, and also enforcement learning. So, one. Okay. So for bachelor's, which this one is a very important topic. It can come both bachelor's level or master's. So for bachelor's, I think that how would you set up a natural language processing pipeline to detect positive or negative sentiment in customer feedback? Include pre-processing, model selection, and evaluation. Remember section C, one question, 30 marks. So you need to be very careful on this one. First, understand the question. Okay, so we're saying, how would you set up a natural language pipeline to detect positives and negative sentiment in customer feedback? So it's like it's online, maybe it's an e-commerce platform, and then you have a section where when people buy from your website, they give feedback. And that feedback can be either positive or negative. Okay. So the question is saying, how would you set up a natural language pipeline, imagine on that e-commerce platform, that can detect positive and negative sentiment in customer feedback? Okay, so as you set up the pipeline, you need to include how you are going to pre-process your data, how you are going to select the appropriate module, and how the evaluation is going to be done. So basically, that's what the question wants from you. Okay. So number one, problem framing in data collection. That's the first thing. Okay. So remember the sentiment, your choice is the positive and the negative one. Okay. So if you don't want to use the binary sentiment, binary because two possible, positive or negative, you can use a mode class, okay, which you can have more than one possible results. So you can, if you choose to go with the mode class, it means you can have positive, you can have neutral, and also negative. But basically the question, even if you choose binary sentiment on its own, it's okay because the question has specified positive and negative. But if you decide to add neutral, you know that you go with the mode class sentiment. Then under problem framing and data collection, you collect labeled customer feedback. So it might be product reviews or support tickets. And then you ensure labels are reliable. So problem framing, we framed our problem. Data collection, we specified what we're going to correct. Product reviews. Okay. So that's number one. And then number two, step number two or second pipeline, data exploration. We are exploring your data exploration. So inspect class balance, text length, common words, okay, presence of maybe emojis, URLs, and language. So the data that you receive, you explore that data to understand. Okay. You'll find other people won't say, they say this was bad. They'll just put an emoji or replying or whatever feedback they might give using just an emoji. So you need to understand how the feedback is so that you can balance. That will help you when you start now training. Okay, if data is in balance, you make neutral positive, but if you choose positive and negative, there's nothing like neutral. You can maintain having just positive and negatives. Okay. So if data is in balance, you actually plan on how you can handle that. Okay. You can plan to do resampling, or you can actually weigh your data. Okay. So after now you explore the data that you have, what next? You need to pre-process it. Okay, you need to pre-process your data. Just Okay, sorry about that. I received a call. Okay, so data exploration. Okay, so you pre-process your data, okay, or your data set that you have. So here, that's where natural language processing basically comes in. Okay, if you go back to the notes that you are given, you'll see that it's exactly what you need. Okay, so from the data that you have in your data set, when you want to train your model, when pre-processing, for instance, the first point we are saying lower casing, so you convert your text to lowercase. Okay, so you make sure that you convert each and every text to lowercase. Then number two, tokenization. You token your words in your data set. So you token your data. Okay, so you split text into tokens. If you remember very well, during residentials, we talked about how you can tokenize your words. For instance, if you've got a paragraph, okay, and then remove noise. Okay. You can remove unwanted things in your data set, things that you think they might affect the accuracy of your model at the end of the day. So you remove the noise, the unwanted data in the database, or data that can affect the model accuracy, the model's accuracy. So we are saying stripe maybe URLs, HTML tags, excessive punctuation, or convert them to placeholders. Yeah, so you can entirely remove them, or you can decide to convert them into a structure that can be easy, or which can be similar with the data that you already have. Then the fourth one, you normalize the data. Okay. Remember, sometimes you might choose to handle some emojis and all that. You need to know how best are you going to handle that when it comes to training your model. So we're saying expand constructions. Okay. For instance, don't to do not. Okay. It means now you have put the slang to a normal way in English. So you normalize the slang. So don't to do not. And then you can map emojis to sentiment tokens. Okay. For instance, when you get an emoji which is crying, you can actually map it to crying. If it's an emoji for smiling, you map it to smiling. Okay, so that way you are pre-processing data, preparing the data, okay, before you actually use it for training your model, so that your model doesn't give you issues or giving you wrong predictions. And then you remove stop words. Okay, this is also important, even if it's optional, but it's important because the more you reduce the size of your data with proper value, the better. So you can also remove stop words, words like there, is, you remove those, okay, and keep the normal structure of the data that you have. And then lemmatization and stemming, also it's optional, but for the sake of having a better model, you can actually also do it. So how do you lemmatize or stem data? You can put them into their root form, the words. Okay, and there are certain words like maybe you say good. Okay, good has got how many letters? Yeah, good, 4. Okay, so if you have the word, for instance, beta, which is BETT 5, so you can remove from beta to good. Okay, And also, for instance, you have running. You can just put run. By that way, you actually have a data set with few words, but which has the same context like the way it was. And then handling misspellings. Okay, also this can be optional, but you can consider in case there are some wrong spellings, you can actually handle that where you put the correct spelling. And then virtualization or embeddings, okay, you can actually embed certain words to a particular based with a sentence. Okay, based with a sentence. And by doing so, okay, you can bag certain words. You can bag certain words by classifying them. It's also under visualizing or giving shape to your data. So bag of words. Okay. Bag of words. You can have certain words that particularly of similarity, and then you can bag them. You can put them together with a single classification. Okay. And also you can embed certain words also to certain words that you have for your data set. That's word embedding. So word to vector, got this, okay. Yeah, and then contextual embedding or pre-trained transfer token. Yeah, so here the keyword is just from handling misspellings, you can actually have word embeddings. You can embed certain words based with how you've classified your data. And when you call upon that word that you've embedded, then it might mean, or you might consider to act on whatever falls under that embedding that you've put. And then once you pre-process your data, you have now data that you think you can use for training your model. Also, you can think of feature engineering, okay, where you can add features like length of text, okay, count of exclamation marks, sentiment counts, okay, and then also presence of maybe uppercase words. But this will be defined if you considered the first option to be, the first point to be option, then there's no need of, there's a need of you considering converting whatever text you have into lowercase. But at this point, we've already done that. So on feature engineering, that might not be important. And then once you are done doing so, you have to now select the model that you can use. What model are you going to use to train your, what model are you going to pick? Okay, that you are going to train with the data that you've pre-processed. Okay, so you might have different types of models. So baseline classical models, you pick the model that you think will best suit the challenge that you have. In your case, is working with the sentiments, whether they are positive or negative. Okay, so you can go with maybe logistic regression. And if you go with logistic regression, you know this one is just like binary classification. So it means when you decide to go with this one, it means on your selection of data there, it's not, you didn't go with multi-class sentiment. It means you went with binary sentiment because you have two possible results. Okay. Unless if you change, you go with multi, it means even here on the model selection, you go with the one that might allow you to have more than two outputs. Okay, yeah, and then Okay, right. Yeah. So here you don't even have to put all these. You just pick one. If you go with a basic one, for instance, you go with logistic regression, you just go with that one and explain about that. If you want to go with the advanced one, maybe you go with the transformers. Remember, we did transformers in deep learning. You can go with the transformers. If you go with, for instance, convolution in your network, okay, you go with that one. In short, here, you just mention the model that you've selected and why you are thinking it's best for the challenge that you've been given. After model selection, you go to training. You have now a data set well processed, and you have now the model that you've chosen. Now you need to go to the part of training the model with the data that you have. So how do you do the training? You split your data into training, validation, and testing. Okay. So this is important because it helps when it comes to achieving the best accuracy of your model. So you can have data that you can just use for training. You can have data that you can use just for validation, and data that you can use for testing. What it means is if you, if you are training a facial recognition model, you can have images for maybe 20 people, but when testing the model after training, you don't use those images. You use other images which you didn't use in the training process. Okay. And then for validating also, you use other images which you didn't use for testing and training. Okay, that is important on training. Okay, and then training takes time, especially with what you are training. For numerical data, it's easy, like the challenge will be given for sentiment. But if you talk of images, videos, that takes time. Okay, so on training, you need also it's best to know, okay, how best you can do the training in a faster way. Okay. So if you're using transformers, for instance, which are advanced, use appropriate learning rates, gradient accumulation for limited GPU memory. So here, when you know you're using the actual computer, your computer, which might have less computational power, you see how best you can work around with a model that you've selected for it to be faster, okay, when it comes to training. Okay, and then number 7, hyperparameter tuning. Okay, so this one also, you can include it based with what you've chose to use when it comes to the model. Okay, so hyperparameter tuning. Okay, we are saying if, for instance, you use the grid search or you use the logistic, which is the Bayesian optimization on validation tests, tune regularization, learning rate, batch size, number of Apple, module layers, tokenizer length. Yeah, so hyperparameter tuning is where you tune how you are going to do the training for your models. Okay, how many times are you going to train your model? Okay, and then the length of or the maximum length of the data that you have. So you can tune the parameters of your training data that you have. Okay, so you fine tune. And once you are done training, you can now evaluate your model. Is it accurate? Is it not accurate? You do the evaluation, which is on 8. So here also, you choose the appropriate method for evaluating. Do you want to check the accuracy? Do you want to check the precision? Do you want to check the F1 score? Okay. Do you want to check the errors using the maybe confusion matrix? So here we've indicated almost 4, but it doesn't mean in the exam you have to write all these now. You just pick whatever evaluation metric you've chosen. If it's accuracy, you go with the accuracy. How are you going to check the accuracy of the model? If it's the F1 score, you just target that one. Okay. And then for the thresholds, here you can choose the activation function that you can use on the thresholds. Okay, you can use maybe the sigmoid on the output side, okay, where you have 2 possible results. In your case, remember already, positive, negatives. So on the output, a sigmoid can be a good idea to be used. And then deployment consideration. Okay, so remember, you might choose to train your model and everything within your local machine, but in terms of online infrastructure, you have main platforms that you can use with high computational power to do whatever you want to do that you can do within your local machine. So if you decide to deploy your system, then you can decide to consider number 10. Okay, so you can check and see which one you would deploy. You can consider deploying the system. Okay, and yeah, robustness in special cases. Okay. Yeah, so for strong steps. Okay, so mainly on number 8. Okay, or number 9 particular, you can end on number 9. But if you want to have a full, you can end on number 10. Okay, it means now you've talked about the pipeline, okay, of classifying the sentiments into positive and negatives. Okay, so that's a whole procedure that you can decide to follow. It doesn't mean you have to go and master to say, okay, number 1, it has to be, no. Depending with your system, even these certain things, you can even shuffle them here. But there are certain things that might come first before the other. For example, data pre-processing. You can't pre-process on the output side now. So there are certain things that you know should come first, but other things you can even shuffle them, depending on how you want your system to be. Okay, and then this one, maybe I'll just do a very quick one. I've just realized this is already 2210. I think it's for reinforcement learning. So you're saying in reinforcement learning for autonomous driving, what are the reinforcement learning components? Here there was even a leakage already. We are saying agent, environment, reward. So how it states, how is state representation extracted from visual data, okay, and what challenges arise, such as sample efficiency and safety. Okay, so here there was already a leakage. Okay, what are the reinforcement learning components? Okay, so you go for the components. We are saying agent. We know what an agent is. And then environment, if you remember, we know where an agent interacts is basically an environment. So, and then state, okay, which is what agent is. Okay, so I think I gave, during the essentials, I gave an example of that game. When you reach a certain point, okay, you need, if you haven't started moving, you can define the state of that one. Okay. And then an action is, for instance, you reach a point where you have 3 roads. You have to choose which road am I going to do. When you make that decision, basically it means that's the that's the action that you've taken. The reward function on the part of reaching the final goal or reaching a dead end. You can either receive a negative or a positive reward. Okay, and then policy or value function. For this one, when it comes now to learning, the same movement that you've made to reach the final goal, what is important is learning from that movement. So that next time, if it was a dead end, you don't choose again the same route. Okay. So we talked about the Q learning. Okay. Talked about the Q learning and other learning modules that you can actually use. Okay. So we are saying learning mapping policy from steps to action possible with value-based component, which is the Q learning. So on the reinforcement components for autonomous driving, basically these are the ones. These are the ones. In driving, it's just that example I gave you. It's just the same. Even on the actual autonomous vehicles, they just use the same principle. Then the second question was, how is state representation extracted from visual data, and what challenges arise, such as sample efficiency and safety? Okay, so state representation from visual data. Remember now we're talking about the actual vehicle driving itself. So it means there must be visual data. It needs to know now people are crossing. Here now there are robots. Here it's a dead end. There must be visual stuff. Okay, so under state representation from visual data is basically extracting important information from the visual data. And we need a model, okay, that can best work with visuals. And CNN is the best for that. No wonder here you see that even when you are dealing with the reinforcement learning, you can actually fuse in models to do with neural networks that can help achieve what you want. And in our case, we've just fused in evolutionary network, okay, to extract the features seen on that particular road, and then help when it comes to deciding when to move and when not to move. Okay. So you do feature extraction, you go with CNN, and then sensor fusion. You can combine even with other cameras that have got sensors. Okay, off the visual, sometimes sensing can also help when it comes to an autonomous vehicle. Okay, because there are things that are down the vehicle that might not really need a camera, and that's where sensor fusion comes in. You combine both the features of what the camera can extract and what can be sensed within that particular environment. Okay, and then temporal representation, use recurrent network. Okay, frame velocity, motion, and understanding. Yeah. So also you can have a temporal representation where you use flames to actually extract certain info from things that might be captured in that particular road. Okay. And and also object level representation. Also here, there might be certain objects, okay, and then you need to extract, you need to know those particular objects by using certain models, pre-trained models that you can use. For instance, you can use YOLO here. Okay, you can use YOLO to identify different objects, and with a combination of cameras with sensors and convolutional neural network, you find that you handle both objects and also things that you've put in the data set. So in the data set, you might not have all objects. You might have things that are commonly seen within loads, but you might also need to identify objects, okay, which are not in the data set, and that's where you can actually use that. And the question was saying, and what challenges arise, such as sampling efficiency and safety? Okay, so challenges, sample efficiency, okay, safety and risk. Partials are variability and sensor noise, long horizon credit alignment, okay, sim to real gap, okay, regulate and difficult constraint. Yeah, I think for the challenge, they're actually straightforward. In short, you're saying what are the challenges of having a vehicle which drives on its own by using reinforcement learning, and maybe what you've used in for neural network. So many things can happen. What if whatever you have in the data set is not exactly what the vehicle has found? Sometimes there can be an accident. Who to blame? All those. There might be a number of challenges. Or what if something just obstructs the camera? It means it won't function. So there are a number of challenges that can come in, and those are the ones that you can definitely add on the challenges. Mitigation and best practices. Okay, it's not, at least other countries, you find that internet is all over because they use satellites. But in countries like Zambia, there are certain places that doesn't have internet. No wonder they are saying use offline reinforcement learning from human driving logs to learn safe policies within risk exploitation. Okay, so you can have mitigation and best practices for reinforcement learning. Basically, what you've been taught concerning the autonomous vehicles. Okay. Okay, use safe reward shaping and human in the loop oversight during deployment. Yeah. So you can use safe reward shaping and human in the loop. So humans also, even if you nicely train your model and everything, but you can put humans in the loop also to oversight the deployment and the use of the same autonomous vehicle systems that can be constructed. So also this one, if you just have a good understanding of reinforcement learning and also maybe deep learning, you can see how best you can put them together. There is no correct order to say you need to start with this, you go, no. The way you might say, okay, I think for me, I can do it this way. As long as they are correct, then it's just okay. More especially on this part for the challenges, okay, efficiency and also safety. You can explain those in any order as long as you justify why you've said so. Okay, so the remaining ones, I think you can find time to go through them. I'll share this document so that it can be a guide in case you are going to see how best you can answer them. But if I use LaTeX, all these formulas, you'll be able to see them as a normal formula. Here, Word document doesn't have all the formulas, so it's hard to display them. So I think I'll use LaTeX and then I'll share the document. So I think we'll end here, unless if there's any question that you'd want to ask me, then I can attend to that.
Good evening, sir.
Evening, thanks. How are you?
Fine, thank you. So, sir, will the exam cover everything we've looked at today, including what we covered the first time we had online session with you, where we were searching for, I don't know if what, dealing with nodes, where would start searching from a particular point, we start moving, that module you shared with us, is it going to cover both that one and this one?
Yeah, so this one is just a tutorial sheet. It wasn't like a class. It's just a tutorial sheet. A tutorial sheet just helps you to understand how you're supposed to answer questions, and possibly some of the questions maybe might come from the tutorial sheet. Who knows? It's just important to go through the tutorial sheet and understand it. But it doesn't define what's going to come in the exam. So whatever we covered during residentials, is basically what is going to come. Okay, is what is going to come, starting from the same reinforcement learning. I don't know if did we do extended reality? Did I do extended reality with you for the master's?
No, sir. For us, this is the second session we're having with you, so it's a bit tricky to know what you covered during residentials because we never had class with you. So I was maybe thinking there's going to be some sort of a guide on how the exam will come, especially
You
that
didn't
not
attend
all of us.
residentials?
Pardon?
You didn't attend residentials?
We did come for residentials. We just never had class with you for AI. You said we would do it online, but this is the second session with you.
For masters.
Yes, master's semester 2.
But you attended for bachelor's, right?
Just once, we found you almost done with class.
You know, I'm always confused with the groups. I don't know how they put them. But what I know is